In the previous lesson, I gave you a graph, a bell curve, and then this is standard normal, the mean is equals to 0, and then I cut a piece and then tell you what this value is, and then I am asking you to find this probability, right? So this, when this happens, you given a z, and then you want to find probability, you use normal CDF. What if for this graph A, B, and C, what if I have an area and I am looking for a Z? I gave you what the area is. I am asking you where to cut the graph to get that area. Then what do you do? How do you do it? So for example, graph A, how do you do it? Are you going to try different Z until you get 0.3520? Of course not. So when that happens, we have to use inverse normal distribution. So inverse normal distribution. You use inverse normal distribution when you know the probability and you want to find the cut, find Z. So this Z, you have to do inverse norm, and then inverse norm, you have to do a left area, and then a mean, and then a standard deviation. So where do you go? You press second VARS, and then you find normal CDF. So press second VARS, and then you normal CDF, and then you find inverse norm. So press second VARS, and then you look for inverse normal, inverse norm. And then once you press inverse norm, you will see this menu. You have to input the area, and then the mean, the standard deviation. The mean and standard deviation, they are always 0 and 1 because Z is after standard normal. And then not all calculator has this tail option. What is the tail mean? The tail means is the area on the left, on the right, or in the middle. So that is the tail mean. If you don't have it, that means left. Again, if you do not have tail option, that means left. By default, the calculator assume that the area you input is the left side. All right, let's do this. So the first one, what do we have? We have area (0.3520). So this is my area. I am looking for this Z. Okay, so this is an inverse normal problem. So we have area, we want to find Z. So let's take out a calculator. What do? You go to second VARS, and then you find inverse norm. So this is inverse norm. I mean, Z is equals to inverse norm, the left area 0.3520, the mean is 0, the standard deviation is 1, and then you will be able to find the Z. So let's do it. Second VARS, and then inverse norm, you input the area. So if you don't have this menu, if you don't see a menu, once you pick inverse norm, the calculator return a command to the home screen, just like what I have in this video. Don't panic. All you have to do is you input the area first, 0.3520, and then you hit a comma, 0, hit a comma, a 1, and then you close parenthesis, you will be able to find a Z. That is negative 0.380. For the Z, I would like to keep that in 3 decimal places. So that is number 1. And then number 2, let me change color for number 2. So for number 2, you have another bell curve. You have the mean in the middle, that is 0. This time you have an area on the right hand side. This is 0.0233. So what do you have to do? You have to do Z is equals to inverse norm. I know the area is always left side. We can still do it. Trust me. Just put the area in 0.233. But you know that this is on the right because you can see it. It is on the right hand side. The mean is 0. The standard deviation is 1. So this, let's do it first. We have second VARS inverse norm 0.0233 comma 0, comma 1, and then you input enter, you have a negative. Is this right? Negative 1.990. Of course, this is not the answer yet because this z is on the right hand side of 0. We remember how the number line works. You have 0 right in the middle. What kind of number is greater than 0? Positive. What kind of number is less than 0? Negative. So that means you have positive z on the right and negative z on the left. This one, they gave you a negative z because the calculator assume that this area is on the left. Again, you don't see the tail option in most of the calculator unless you brought the most recent the newest calculator. Unless you have that, you don't see it. That's fine. They assume the area you input is the left side, but this one I need a positive. What is the correct answer? The correct answer is this is a left z, and then the z on the right is positive 1.990. All you have to do is you remove the negative side. How come we have one negative on the left and one positive on the right? The answer is that relates to one of the characteristics of this bell curve. The curve is what? The curve is symmetric. You have a negative 1.9 on the left, you must have a positive 1.9 on the right. And then the last one, this time we have two cuts, one on the left, one on the right. Let's call this a Z1, this is a Z2. This is a 0.475, this is 0.475. What is the total? Or actually, you don't need to calculate the total. Let me switch color for this. I cut this right in the middle. We have 50% on the left and 50% on the right. This is 0.475. So if you take 1, if you take 0.5 minus 0.475, so you take 0.5 minus 0.5, then you get the leftover, right? 0.475, then you get 0.025. So this is 0.025, this is 0.025. So that means what we are doing is this. I need the 0.025 to find my Z1. I know that it's not the area that we are looking for, 0.025, but I need to borrow this for now to find the Z1. So the Z1 is equals to inverse norm 0.025, 0 and 1. Let's get that. So we have a second VARS inverse norm 0.025, comma 0, comma 1, and there you go. That is negative 1.960. So we have negative 1.960. And then the Z2, what is Z2? Z2 is positive 1.960. One negative, one positive, because the graph is symmetric. So that's how you find all three of this. Okay, I know 3 problem is never enough. Let me give you more exercise. So the first one that I want to give you, let me switch to some other colors. The first one that I want to give you is I want to have a 20% on the left. Okay, so this is a 0. I want to cut 20% on the left. What is this Z? The Z is inverse norm 0.20, 0 and 1. Let's calculate that. Can we just do it like that? Maybe that is too small. Second VARS inverse norm 0.20, mean is 0, standard deviation is 1, then this is negative 0.842. So that is the first one. And then the next one, how about 47% on the left? 0. So 47% on the left, this is my Z. How about that one? That one is Z equals to inverse norm 0.47, 0, 1. So second VARS, inverse norm, 0.47, mean is 0, standard deviation is 1. And then that is negative 0.075. Do I need to remove the negative? No, because the 20%, the 70, the 47%, they are on the left. We do not remove any negative. They are on the left. 0 is in the middle, negative on the left, positive on the right. Remember, negative on the left, positive on the right, and then 0 is in the middle. Let's do a couple problem where the area is on the right. So let's do how about 35%? So we have a 0. How about this? 35% on the right, and then we have a z. So this z is inverse norm, 0.35, 0, and then a 1. What is that? Second VARS, inverse norm, 0.35, 0, comma 1. So that is negative 0.385. Do I need to remove the negative? Of course, because this z is on the right hand side. So this is on the left. The one that we want is positive 0.385. That's how you do it. Let's try a 54%, shall we? So 54. How much is 54, by the way? We cut a 0 right in the middle, 50 on the left, 50 on the right. 54% on the right is already more than half on the right. So this is what we are looking for. This is a 54%. I want to get this z. So to find the z, we do inverse norm, 0.54, 0, and 1. So what is z equals to? Second VARS, inverse norm, 0.54, 0, and a 1. So that is 0.100. Is this the answer that we want? Nope, 0.1 is right here. So if you have a 0.1, then you have this 0.1. This is the 54%. But this is on the left. I can see it is on the left. So z is supposed to be, this z right here, z is supposed to be negative 0.1. That is your answer. And then how about 50% in the middle? So the next one we have 50% in the middle. So 0. And then we have 50% in the middle. So 50% in the middle. How much do we have left on this side and this side? So we have 100 minus 50 in the middle divided by 2. We still have 25% on each side, right? So this is a 25, this is a 25, then we have a z, we have a z. And then we do z1 is equals to inverse norm, 0.25, 0, 1. So z1 is second VARS, inverse norm, 0.25, 0, 1. That is negative 0.674. So z2, we remove the negative 0.674. That's how you do it. And then the last one. Well, I'm going to try one more. And then we wrap up this video. 75% in the middle. So this is 75%, 0, z1, and c2. How do you do it? 75% in the middle, that means we still have 25% left, and then we have to slice the 25% into 2 pieces. So we take 100 minus 75, 25 divided by 2, you get a 12.5. So this is 12.5, and then this is 12.5. And then your z1 is equals to inverse norm, 0.125, 0.1, and then C2, you take the positive. So second VARS, inverse norm, 0.125, comma, 0, comma, 1, close parenthesis, and then you enter. So you have negative 1.150. This is positive 1.150. That's how you do inverse normal distribution. Again, inverse normal is given area. Okay, you have to find Z. For normal CDF, you have to given Z, find area. This is equals to area. The inverse norm, the inverse normal CDF gives you an area. The inverse norm gives you a Z value. So that is the difference between normal CDF and inverse norm. Alright, I will see you all in the next video. In the next part, I will give you another example that involves everything we learned in the first couple videos. Alright, I will see you there.